All right. So I hope everybody can hear me okay?
Yeah.
Okay. So let's do a quick roll call. We have Anshu, Arya, Dev, Chris, Rehan, Savya, Sivatsa, Vaibhav, and Vihan. So some of the kids are not able to join today, and some of you are still having extended vacation. So we'll start. So did you guys get a chance to see what all we are going to cover today? Okay. So we will be covering a couple of topics that we had left yesterday, which was completing the square, and then on the top of that we will brush up on the quadratic formula and see how do we apply that for solving complex square roots, and then we'll touch upon the linear and quadratic equation system of equations. All right. So who is missing? Aryan is missing. Arya, would you know if Arya is joining shortly?
I'll remind him.
Oh, okay. All right. So for everybody else, I have information that they'll not be able to join, but yeah, Aryan is the only one. I was not aware. So let's start. So first we look at the quadratic formula. So, and again, quadratic formula as we speak relates to the concepts that we have learned with respect to how do we solve the quadratic equation to find the value of the variable. So, does anybody remember what is the quadratic formula? Yeah, yeah. Okay, yeah, Vihan, go ahead, tell me.
It's y equals negative b plus or minus the square root of b squared minus 4ac over 2a.
Yeah, so it's not y. Mostly when you look at a quadratic equation, it is ax, the standard form of that is ax square plus bx plus c equals 0. And the quadratic formula relates to the solution of x that you can get from any quadratic equation, which is derived as which is mapping to the standard form. So which is minus b plus minus b square minus 4ac by 2a. And again, most of you would be knowing these concepts. We are just doing a kind of recap of what we have learned already. So now, in this quadratic formula, there are certain hidden information that we all need to be aware of. So just by looking at this quadratic formula, can somebody tell me what are the important elements of this formula? There is one very important element of this formula, which lays the building block of this formula, or which acts as a decider with respect to whatever solution you can get. Yes, Chris.
Isn't the discriminant?
Yes. Vihan, was that your answer as well?
Yeah.
So this is the guy. This is the mastermind or the brain of this quadratic formula. This guy decides what will be the fate of the solution that we will get by dealing with any quadratic equation, which is called the discriminant. So I don't remember if the discriminant is the square root of this or only this part. Does anybody remember which one is discriminant? The entire square root or only the b square minus 4ac? Okay. As far as I remember, this is the entire b square minus 4ac square root. That is the discriminant. Now, that tells you that if this value is 0, if this value is 0, what does it mean? If discriminant is 0, what does it mean? Yes, Dev.
Does that mean there's only
me one solution.
It will give you only one solution. If this is greater than 0, what does it mean? You can have two solutions, correct? So basically, if this whole value square root is greater than 0, that means it will give you two solutions, that is one with a plus, one with a minus. And if this discriminant is less than 0, I mean, if this is the third scenario also, which says b square minus 4ac gives you a negative square root. You guys remember? So there are three scenarios. One scenario is when this is all 0, then you have only one solution. If this value is greater than 0, then you have two solutions. And when the third scenario is when discriminant is giving you a negative square root. Our initial going in position was that when you have a negative square root in the discriminant, that means it leads to an imaginary solution or no solution. But when we talked about the complex numbers yesterday, that is when we got rid of the restriction that we had, saying negative square root is something that we don't want to deal with, is history. We can still deal with negative square root by bringing I into picture. Yeah. So that's where this quadratic formula and the complex numbers will add them together to do away with the restriction that we were dealing with before yesterday's class. Is that understood to everybody? Understood by everybody, or we have a question still? Okay. Now let's do one thing. Math doesn't exist if we don't do practice. So let's quickly solve one problem with complex square root scenario and apply the quadratic formula and the understanding of complex root together to work on a solution. So let's do it real quick. I'll give you guys probably 10 minutes to solve this before we jump on to the next concept. Yeah. This is a very simple quadratic equation. I would want you guys to solve this using the quadratic formula and the concept of complex number to arrive at the two possible values of x. Can we try doing that real quick? Again, I repeat, the equation is x square minus 2x plus 6 equals 0. I want you guys to solve this using quadratic formula, find out the two possible values of x, and if you get stuck with a scenario where it gives you a negative of square root as discriminant, that is where you have to apply the complex number concepts that we learned yesterday to solve it. Are you guys okay trying it, or you would want me to solve it first and then you guys pick up the second question? Any which way is okay. Yeah, so you're trying to say something?
No, I was just gonna say I'm fine solving it.
Yes, please. I mean, I would want you guys to try solving it. That should be our first attempt. Always try solving a problem, and if you get stuck, there's an old man whom you can bother. So let's get started. So you guys have next 5-7 minutes for solving it. Okay, I'll go on mute. And I assume everybody is trying to give it a shot, right? Everybody, Chris, Dave, Shivatsav, Vaibhav, Arya, Aryan, Vihan, everybody? Rehan? Okay. Yes, Chris.
Wait, what are we trying to find in this question? I forgot.
So just try solving this quadratic equation. And the only clue we have is, this is going to give you a negative square root scenario. That is where you'll apply the concept of complex number that we learned yesterday.
So you just want two solutions?
Yes, find out the solution for x.
I got one. Should I say it out?
You got one or you got two?
I got two. Sorry.
Yeah, go ahead, tell me.
I got 1 plus minus 2 root 5i.
2 to the power?
No, 2, like 2 outside the root sign, like 2 root 5. It was like negative 20, so
Okay.
it broke down to 2 root 5.
I. That's what your answer is. So basically you have two answers, 1 plus 2 root 5i and 1 minus 2 root 5i.
Yeah, correct.
Okay. Let's see what everybody else gets, and my request would be, don't get biased by what Chris said. Yeah.
I got something slightly different. I got 1 plus minus square root of 5i.
Square root 5i. Okay. Let's see. So that's what I'm saying. Don't get biased. Trust yourself more than anybody else and solve it. Yes, Chris.
But actually, I found out a mistake. I got the same thing. I forgot to cancel out the 2's.
Okay.
Like from the,
So
it's the same thing as she said.
1 plus square root plus minus square root 5i. Okay.
Yeah, that's
So right now we have only one solution, and see, this is where we witness the beauty of review, right? So when Chris reviewed his own answer, he found where he had an opportunity to fix. Good. So yeah, that's a takeaway. Yeah, Vihan.
I got 1 plus or minus 2 root 5i.
You got 1 plus or minus 2 root 5i. Okay. So that answer still holds true. So now we have two answers. It's an opportunity for all of you who have got their answers to validate or review your work so that you would know if you are right or somebody else was right. Okay.
Sir, I got minus 1 plus square root 6i.
Minus 1 plus?
Square root 6.
I?
Yeah.
Okay. Interesting. Okay. We'll see.
I also got 1 plus or minus root 5i.
Okay. So this one has got more votes so far. Okay. Okay. So I'll give 2 more minutes. So Shravya, Dave, Aryan, Rehan.
I solved it and I got x equals 1 plus or minus root 5i.
Okay. So this one has got maximum votes. Let's see.
I got the second one as well.
Okay. 1 plus minus square root 5i.
Yeah.
Okay. Is this going to be the default selection? Let's see.
Wait, I just realized that what I got wrong. I also got the second one.
Okay. So we noticed that Vihan and Chris would agree to the point that review is very important, and that has to be made a practice for all of us. I might go wrong as well, so that's why when I solve the problems, I do step by step so that if I get something wrong, I know where to go and fix it. Rehan, Shravya, Shivatsav.
Sir, I got the same as Chris, but I did a mistake.
Okay, so now I have more kids agreeing to my point of view or my recommendation on doing reviews, right? So, see, this is looking like the only answer that most of you have got so far. Rehan, Shivatsav, Savya.
So I'm still solving it.
Still solving it. Okay. Now, I mean, I just want to give one more minute and then I will solve it because I don't trust any of you. Now, when I say I don't trust any of you, meaning I practice what I preach. Alright, so all of you who have solved it or some of you are still trying to solve it, let me knock off the bias first. I don't know what the answer is. I don't want to know that. So let me solve it. This is my method, right? Tran, the most boring part of my teaching. Just read, analyze and then nicely. Just do it. So I'm reading it. So this is a quadratic equation, x squared minus 2x plus 6 equals 0. I read this question. I know what this question is. Now I'm analyzing it, meaning I can try solving it using the standard formulas that I know, a plus b whole square, a minus b whole square. But the first catch that I had was, this is not a square. So this is not going to cut ice when it comes to mapping with my standard formula, a plus b whole square, a minus b whole square, or a square minus b square. Now the second approach I have is, I'll multiply a and c and see what is the value. A and c gives me, again, a and c when I say, I'm mapping it with the standard form of the quadratic equation. And my a and c is 1 into c. A is 1, c is 6. So a into c gives me 6. Now what are the factors that I can think of? 6 into 1, 2 into 3. There are two factors only. Now if I deal with 6 and 1, whether I do a plus or minus, it doesn't give me a 2. So this one doesn't work. If I look at this option, 2 plus 3 is 5, 2 minus 3 or 3 minus 2 gives me 1. So this one is also not cutting ice for me. So then I am left with the third option, which is my quadratic formula, which is more like a magic wand that we have for solving any quadratic equation. So, which says x equals minus b plus minus b square minus 4ac divided by 2a. Now, my b is what? Minus 2. So, minus of minus 2 plus minus b square minus 2 square minus 4 into a is 1 into c is 6 divided by 2a, 2 into 1. So this gives me minus into minus plus 2 plus minus square root of minus 2 square is 4 minus 4 into 1 into 6, 24 by 2. So here from this I got 2 plus minus square root of minus 20 by 2. So 2 plus minus square root of 20, I can put this as minus 1 I will take out because I know it says minus of square root, that means I have to deal with complex numbers. So I will make this minus 1 separate, 4 separate and 5 separate by 2. This becomes 2 plus minus 4, square root of 4 gives me a 2, I will take 2 out. Then minus 1 is nothing but I square. So square root of that gives me I. And then I am left with 5. So here I can take 2 common. So 2 comes out, 1 plus minus square root 5 times I by 2. This and this gets done. Tic-tac-toe. So we are left with 1 plus minus square root of 5 I. So I believe everybody got the same answer. So did I. So now I have a reason to believe you guys. And we all did it the same way. Okay. So all of you who solved it following these steps got the same answer. Even if you tweak a little bit, you did faster than the time that I took, still we got the same answer as the approach was fine. So whoever was still trying to solve it or was close to being done, just you can use this as a reference to revalidate if you are following the same path or you took a different approach. Yeah. So Rehan, Savya and Srivatsav, you guys were still doing it. So I'm assuming this is what you would have done if I would have given you a little more time. Yeah. Yeah. All right. Are you good to move on to the next topic? So I'm not touching upon that. So what we did was yesterday we learned, or yesterday we we learned the complex number concepts where we came to a point that if I get to a situation where I have to deal with minus of a square root of a minus or a square root of a negative number, we should not stop there. We can use the imaginary number I, which is nothing but square root of minus 1, to continue with our calculation thereafter. Yeah. So this is what connects the dot between the quadratic formula and the complex numbers that we have learned yesterday. Is everybody with me so far? Okay. Anybody would want me to look at any other concepts related to this one before I move on, or we are all good? Everybody is good? Ananya, Anshu, Sivatsav, Grace, everybody okay? Okay. Alright, so what was our next topic? Next topic was finding out or completing the square. What does it mean? This is the fourth method that we can use to our benefit when it comes to solving a quadratic equation. So far we have talked about the standard, relating things with the standard formula a plus b whole square, a minus b whole square, or a square minus b square. Second approach was when we looked at a and c, multiplied that and used that factor for deriving or relating with b. That was our second approach. And the third approach was the quadratic formula. So completing the square is potentially the fourth method that you can use. Now let's see how does it work. So if let's say we have an equation like x squared minus 6x plus 2 equals 0. We have three methods, three approaches that we can use. The standard formula, the quadratic function, or the a and c, and using that. A and c, multiplying a and c and deleting that with b2, split that into two parts and then go ahead. There is a fourth method which says when you can complete the square, meaning what does it mean? It means that whatever you have in the quadratic equation, you can convert that into a square form or the standard formula form, a plus b whole square or a minus b whole square form. And how do we do that? Now if you look at this situation, I have x square minus 6x plus 2. This is not a square. So this is not a given square situation. We have to convert that, or we have to add or basically manipulate in a way that it becomes a square. Let's look at it. If I have x square minus 6x plus something, and then I have a 2 already, equals 0. If I can put something here, so that this part alone becomes a square. What will happen is, this becomes a square, then you know that, okay, let's say if it is x plus, let's say 3 square, and then you have something 2 or 15 or whatever. Then you know that, okay, x plus 3 square will be equal to, let's say, minus 15. So you know that x plus 3 will be square root of minus 15. And then you know how to deal with this. So instead of memorizing the quadratic formula or going with other methods, you have other option where whatever you have, try to form that like a square. So let's see how do we do it. Okay. So then probably I'll make more sense, little more sense. So I have x squared minus 6x plus 2. I'll keep 2 parts somewhere else. Okay. I want to put something here so that this piece alone becomes a square. What do? This is x squared minus 6x. So 6 is 2 into 3. If I add 9 here, okay, and whatever I have here, So I added 9. I did not have a 9 before. So I will add a 9 this side also. Why did I do that? Now this becomes x squared minus, so it is x squared minus 2 into 3x plus 3 squared. If you look at it carefully, it is x minus 3 whole square. This became x minus 3 whole square plus 2 equal to 9. So this is x minus 3 whole square equal to 9 minus 2, which is 7. So x minus 3 square is 7. So you will say, okay, fine, that means x minus 3 equal to plus minus square root of 7. Do you think I'm making sense so far? Or are you guys able to follow me so far? Yeah. So now this gives me two solutions. So x minus 3 equal to plus square root of 7, or x minus 3 equal to minus square root of 7. So I have got two solutions here. So in a way, if you look at it, I am not trying to say that this is simple or difficult or or complicated than other methods that we know. This is just another method where if you find this more conducive, more easy to follow, you can use this method as well. So this is called completing the square. Whatever you have, add or subtract something to make one part is a square, and then everything else goes to the other side. So on the right hand side you are only dealing with a constant, and this side you have a square. So that way you know that, okay, if I have square as some value, then I know square root on both the sides and I get my possible answers. Are you guys with me so far? Everybody able to follow me? And I will keep on poking everybody who doesn't respond, or who takes a little longer to respond, just to make sure that I get the confidence that, okay, everybody has been able to follow me. Okay. So Dev, Ananya, Shravya, Rehan. Okay. Can I assume everybody understood? So then if you say you understood, then that gives you another opportunity to solve it. Solve another problem. Let's try using this method of completing a square. There is nothing new here. It's just about applying the standard formula that we know and how do we try solving it. So if I give you an equation 2x square plus 16x plus 3 equal to 0. Or let me make it little easy. Plus 6 equals 0. Can you guys try solving it using the method of completing the square? And just to give you guys a clue, it is about completing the square. At the same time, I am using another method where other part of the concept where you can multiply or divide a quadratic equation by a certain number. So that's why I purposefully multiplied by 2. So you can use that understanding to simplify it and then deal with it. So can I assume that everybody is trying? I mean, do you guys want to give it a shot, or you want me to solve it? Okay, Arya is trying. Anshu, Vihan, Vaibhav, Sivatsav, everybody is trying. Okay. Okay. I'll not ask everybody one-on-one, but yeah. My request would be try solving it, and once you get stuck, that is what will make me happy to solve it. Alright, anybody close to being done? Yes, sir,
No, I was just saying I'm almost done solving.
Okay, okay. Yes, sir,
I got an answer.
Okay. Good.
I got -4 plus or minus the square root of 13.
Okay. So, yep. Let's see if we get any different answer or same answer from other kids in the class. All right. 2 more minutes.
Sir, I got 4 minus square root 13i.
Okay. 4 minus 4?
No, 4 minus.
4 minus. So you got only one answer?
4 minus 39. I mean square root 39.
So this was your answer? Okay. So you're saying that you got only one answer?
Yeah.
Okay. Yeah, I'm sure.
I got -4 plus or minus square root 13.
Okay. Plus minus 13. Okay. How about you, Chris?
Yeah, I got the same thing as RN answer.
Okay.
Also, sir, it's plus or minus, my bad. Yeah, plus or minus.
Plus minus 13i.
Yeah.
Okay. So I have got two set of answers. One is plus 4 plus or minus square root of 13i, and the second one is minus 4 plus minus square root of 13. Okay. All right. So then we had. What did you get?
I also got -4 and then plus or minus root 13.
Okay. All right. So we got a few sample answers already. So let's look at, and I'm pretty sure everybody else is trying. So let's see how the teacher would solve this. So if I have something common, okay, like 2x squared plus 16x plus 6, our first goal is to always simplify this. So if I have 2x squared, it doesn't, or 2x squared or 4x squared, whatever it is, right? When I have something more than x squared, that means my job is going to be complicated. So our first attempt would be simplify this. So that's what I'm doing as part of my analysis. Okay, I see that I have an opportunity for simplifying it. That's the first thing I would do, and then obviously I'll try converting this into a square form. So first thing I'll do is I'll take the common things out. So that means, or I'll simply divide the whole thing by 2 because I see that 2 is common. So I'll simply divide the whole equation by 2 and that doesn't change my outcome. It's as good as you divide by 2 on both the sides and this becomes your new equation, which is a much simplified equation. Now I have x squared plus 8x plus 3. Let's keep 3 little far and see what do I add here so that this part alone becomes x squared. So if I see this, it is x squared plus 2 into 4x plus something. So a square plus 2ab, this is my b, so this will be my b square plus 3 will be, so if you look at this, what did I do? I added 4 square here, so I had to add 4 square this side also. So what I had a 0 before, I added this part. So this becomes x plus 4 whole square plus 3 equal to 4 square, which is 16. So x plus 4 square equals 16 minus 3, which is 13. So my x plus 4 square is 13. So x plus 4 will be, basically I am doing a square root on both the sides. So x plus 4 will be equal to plus and minus square root 13. So now my two solutions are x equals minus 4 plus square root 13, and let me not jump one step. So I will say that means x equals minus 4 plus minus square root 13. So I have two answers here, one is with the plus, one is with the minus. So Vaibhav, do you want to look at why did you get an I?
No, I don't say I.
You
I
did not?
said
Oh, okay. I heard I, that's what I have noted down. So yeah, okay. Then you're fine. Okay. So this is, again, I mean, if you look at the solution, right, I mean, I don't teach anything complicated, right? I teach only simple things to you guys. Complicated things I'm leaving for you guys to study by yourself. So if you look at the whole concept of the sequence of events, right, it is done the simplest possible way, step by step. So you don't really have to break your head to find out what is the complex part of the solution. It's as simple as, okay, I have something, let's simplify it first. Once I've simplified it, is it looking like a square? No. So let me not worry about 3 and other things. Let me keep 3 separate and convert this to a square. For this to be converted to a square, I have to add this. So if I'm adding this, which was not there before, that means I have to add it this side also. So that is why it came to this form and then this. So I know it's very cold, but is this understood so far? Everybody? Okay. One honest question or a very candid feedback that I need from you guys. Whatever I have taught so far or whatever I teach to you guys, do you find this easy to follow or sometimes I make it complicated? And you can be honest, see, I'm not teaching it for myself. If you guys find it easy to understand, my job is done. So that's why it's very important for me to keep on getting feedback from you so that I can keep on tailoring it to make it more effective for you guys. So that's what I'm trying to understand, that what is the feedback from my kids? And you can be honest, okay?
What is it? Sir, it's
Easy to understand? Okay, that's one feedback. How about you, Anshu? You are the latest child in this family, so tell me.
Yeah, I think it's like easy to understand how you explain it and you can
Okay.
take care of. So.
Okay, that's good. Aryan, Dev.
It's easy to follow, sir.
Okay, that gives me a little more confidence, and I certainly need to be confident while teaching you guys, right? So that's why I keep on forcing you guys to get your feedback so that I can work on my weaknesses. It isn't. Okay. All right. So this takes care of the second concept that we wanted to learn today, and the next one or the last one is the linear and quadratic systems. So again, you guys have dealt with linear equations or system of linear equations enough. You have dealt with quadratic equations enough. This is a combination of both the concepts that we have learned. So again, my bad, Vihan, it's a question for you also, because you are also very fresh to the class. So are you finding it easy to follow me, or?
Yeah, it's relatively easy.
Oh, okay, good. Because I never claim to be very intelligent, okay? I'm not a very intelligent person. So that's why I try to explain things in a way that I would understand myself, right? So that's the primary goal I have in mind, that if I can understand, anybody else can understand. So that's why I try keeping things simpler, okay? All right. Now, the next thing that we wanted to talk about is the system of linear and quadratic equations. And again, you guys know what is a quadratic equation, you guys know what is a linear equation, how do we deal with that. So we will not learn anything new, we'll just kind of try connecting the dots. Now let's say I have two linear equations, let's say x plus 2y equal to 6 and 3x minus y equal to 8. Since I have two equations and two variables, you guys know that you have multiple ways to solve it and get the exact value of x and y. Correct? Or let's put it this way. If I have just one equation, what does it mean? It means that I can get infinite combination of x and y which will satisfy this condition. Correct? There is no one solution right now if you have just one equation. Correct? I need just one yes.
Yes, sir.
Okay. So again, as I said, this is a linear equation. So when you have a linear equation, as you all would know from your early learning experience, that you convert this into x and y table. You put different value of x and you find out the corresponding value of y, satisfying this equation, and then use this coordinate plane to plot those points and connect them. That draws a line. That's why it's called a linear equation. This part is known to you, and you would hate me if I explain this one more time, unless you want me to. But then, this is one linear equation. So what's happening is, every point on this line is satisfying this contract. Every point will satisfy this contract. And what that means in physical terms is, these are the infinite combination of x and y values which will satisfy this condition. So you have infinite solution of x and y. Just with one equation, you will not get one solution. You will get infinite solution. Right? It's little contrary to what we say, right? I mean, you say you put less money, you get less interest in the bank. Here it is like you put just one equation, you get so many solutions. In contrast to this, if you have two equations or 8, this gives you perfect one solution. Yeah. So if you have two equations, it will help you solve for x and y and give you one unique solution if these two lines intersect each other. Right? So there are two ways of solving it. You can solve it using algebra, or you can solve it using regular graph by plotting it on a graph paper, and wherever it meets, the x and y coordinate of that point is your solution for x and y. This part is clear to you guys, right? I mean, I am just doing a recap, but in case. Now, life doesn't change much if you introduce a quadratic equation along with a linear equation. So let's say I had a linear equation like this, which probably, let's say, I'm not going to find out the table and then plot it. I'm just saying that this draws a line like this. I'm just making it up. Okay. Now, if I had another linear equation that would have drawn another line and they would have intersected each other at some point, and that would have been my solution for x and y. But let's see if I had x squared plus 2x equal to y. So we got an equation for a parabola or a quadratic equation, whatever you call it. What will that do? That will plot a parabola. And at most it can intersect the line at two places. It may or may not intersect also, but maximum possibility is it can intersect at two places, or if the parabola is not friend with this line, it will be drawn somewhere here, it doesn't intersect. So you are looking at different situations. One situation is when this intersects at two places, you have two solutions for x and y. So this point and this point both will give you two values of x and y. And you will say why? Because if you look at any quadratic equation, a quadratic equation always gives you two solutions. So likewise, when you connect one quadratic equation with a linear equation, at most it can give you two solutions for x and y, which will be lying, these points will be lying on this line as well as the curve. So it's just to relate that a quadratic equation when we dealt with, we knew that we can get up to two solutions for the value of x. When I did not have a y, I can get up to two values of x. And a linear equation gives me only one solution when I am dealing with two linear equations. Here when you combine a linear equation and a parabola or a quadratic equation, you can get up to two solutions. So it is just to relate the concepts and say that okay, if I am dealing with system of linear equations, I can get up to one solution, maximum one solution or no solution. If I am dealing with a linear equation and a parabola or a quadratic equation, I can get up to two solutions. It can intersect only at one place, or it can intersect at two places, or it might not intersect at all. So if it intersects at one place, there is one solution of x and y. If it intersects at two places, I am getting two pair of x and y values. And if it doesn't intersect at all, if the line goes like this, you have no solution. So these are the situation or the possibilities that we might come across depending on what kind of equation we are dealing with. But good thing is, there is nothing new that we are learning as part of this. Whatever we know, we are just going to use that understanding, that knowledge for solving the combination of linear and quadratic systems as well. So with that being said, I'll probably stop for a while just to see if you guys have any question or any doubt around this which you would want to touch upon before I let you guys go.
I just have a question real fast, like about the standard form. I know that B is C, like C is the y-intercept and B is the slope, like when you have the ax squared plus bx plus c. But what is the a? Like, because sometimes like on the SAT they ask for like define like a and c and stuff like that, and like.
So if you're talking with respect to quadratic equation or linear.
It's like standard form, but also like the quadratic equation.
So if you look at this, ax squared plus bx plus c, y equals this, right?
Mm-hmm.
So now you tell me what is that you know, and then where you have something that you want me to clarify.
So I know that B is the slope, right? I know it's just like it's supposed to be the slope, and then like C is the y-intercept. Like, cause yesterday like I just got a question where like it gives you like it asks you to find what B times C is, and it gives you like the graph.
Mm-hmm.
But like it just gives you the graph, and then it tells you. I think it gave you the value of A. and then it just wanted you to find BC, like B times C.
So what I would suggest, Anshu, is you send me the question, because see,
Okay.
when you're dealing with a quadratic equation, there is no given slope, okay? Because your
Yeah.
slope keeps on varying, right? So that's why I want to take a look at the
But I
question.
think the thing is like
Uh-huh.
they give you the A and then like you're supposed to find the C is the y-intercept, right?
Yeah.
Yeah, so it gives you the like, C, so I think it wants you to find it because you have an A, it's just you have to find
So yeah, so these are relatable concepts, okay? So let's say if you have this equation, right? You said C is your y-intercept. Now, when you say y-intercept, what does it mean? Meaning where it is, the x value is 0. So what we did, you put x equals 0, you get a C. And you know that, okay, at which point it will intersect the y-axis, correct? So these are the concepts that we have to relate. That's why I'm curious to see the question, and then probably I'll be able to explain that in a better way.
Yeah, I can send it. I just know there's a lot of questions like that which like rely on like
I would.
A, B, and C, but they don't give you it. They want you to find it, and those are like a lot of the types of questions that I have trouble with. So if I like, I can send you that one.
Yeah, please send me few questions actually. Whatever you have come across in the past, send it across to me. I will go through it, and then I will try picking up that in the next class to explain that in a more what you call the lame possible way, which is my way. Yeah.
Yeah,
Sure.
I can send you the questions.
Yeah, send me a few questions so that I also will get a sense of what kind of questions you have seen, and which could be relevant for the whole class, right? So that's the purpose. When you guys share things among yourself or with me, at least that gives me an opportunity to bring everybody on the same page. Yeah.
Yeah.
All right. All right. So the younger kids have started joining, so I'll let you guys go. Enjoy the rest of your evening, and best of luck for the school starting tomorrow.
Thank you.
Thank you,
All
sir.
right.
Master.
All right. Bye bye. Bye bye. Yeah.
One more question.
Yeah. Yeah.
Wait, so we didn't have class